Very cute.
Alright, cool.
Like working here, he's reading like his friend was trying to hook up with my friend's roommate. So like we all ended up like at this apartment. Never worked out with his friend. And actually that friend is getting married on Friday, so we have to like head out to Long Island. That's fun. Why we get married? Like here's like a wedding ring for everybody else. No, I always look like family stories. Okay. Like I feel like this is like a he was never like super close to his friend, like over time. Yeah, kind of like we had terrible like I don't know the bride, like she, yeah, it's really fun. Like, so I feel like we're just gonna be like kind of like watching, and then you know, meet that person, yeah, that like horrible party guy. Yeah, maybe. I always feel like
Awesome. So sorry for the delay here. So all right, let's get started. So before we start, I want you guys to introduce you to someone who will introduce herself, actually.
Hi, I'm Danny. I'm here to help you guys. So I just completed the part-time boot camp, so I just fresh out of that. If you have any questions about that, just anything. Yeah.
Yep. So myself, Danny, and then the fellows behind you as well will continue to be resources. I'll be walking around, during the workshops, answering any questions you may have, and to kind of help you think through some of these things. Sound good? Cool. All right, good. All right. So let's get started with today's workshop. Today's workshop I'm super excited about because it's talking about things that I think you will almost see in every single block of code you will ever read for the rest of your life, right? And those two things are operators and loops. And they're both very, very important concepts because of how prevalent they are. Really, something like a loop is heart to what makes programming so powerful, right? Like if I was to say, if I was to tell someone to say, hey, can you write a word for me, right? It will literally go on the board or a piece of paper and manually write it. If I said write it for me 10 times, right, it would take them, they would need to go back and do the same thing 10 times in a row, right? It's not very highly repeatable and takes a lot of manual effort. What loops allow you to do in a programming setting is to do things in a very repeatable manner without having to exert much effort. So as we go through these slides, I'll just be illustrating some of these concepts on the board in a way that hopefully helps you understand what's happening behind the scenes. Loops are very common. Yes?
Can you turn off the lights?
Oh, sorry. And it's always a trade-off because if I turn off the lights, I think you'll have to see the board. So I'll just switch on and off between these. Cool. So loop here is defined as a generalized solution for repeating code with control over how many times the block of code runs, which is a lot of words and probably don't mean much to you right now. But hopefully by the end of this lecture, you'll get a much better sense of what we mean when we say, loops are very, very powerful, and knowing how to understand loops is fundamental to understanding essentially how to program. So let's just say we have a particular piece of code, right? That we want this code to do something until a condition is met or not met. Okay. So what that means is we initially start off with something we call a condition, right? Like basically this means I want you to do this until blank, and that blank is a condition, right? So that condition could be something as simple as until this variable is equal to true, or until this count equals something else, until this number hits a limit, right? This condition could almost be anything, but it needs to be something that eventually we're going to reach. Because one of the things that's very dangerous about a loop, and really with most of these concepts in general, right, is that when you make a loop, one of the first things you need to keep in mind is, when do I want this to stop? Because computers are, they're very smart, but they're also not that smart. Because a computer could just, if you tell it to do something over and over again without giving it a stop point, it will just keep doing it over and over again until it breaks. Or more likely than not, in modern computers, until it throws you an error and says, you've exhausted all the memory in your computer, or you've done something and I don't know how to handle it, right? So computers, if you don't give it a stopping point, it will just keep going. It will just keep going on infinitely. So, too many arrows here. Okay, so all this is saying is that we start off with a condition, all right? And we evaluate this condition, and we ask one simple question is this condition true, right? If it's true, then we say, great, let's do the thing that we were supposed to do, right? So if I say, write 10 words on the board, right? Someone writes 1, and it's like, well, should I keep writing? My condition would be well, do you have less than 10 words on the board? And if the answer is yes, I have less than 10 words, keep going, right? That's all this loop is saying. It's saying we have a standard that we need to meet. Let's see if we've met it, right? And if we have, then we're going to execute that piece of code. However, if we keep going enough times, assuming we wrote this loop properly, there's going to be a point in which the condition is going to tell us, no, stop. Like, you've done what you're supposed to do. You've hit your limit. You're at capacity. Stop doing what it is you're supposed to do. And then, oh, that was a really aggressive next slide. But basically what that means is once you reach the end of the not condition, the loop ends. Or in programming, we say the loop terminates, which means that the loop has done this thing the number of times that it was supposed to do it. It's reached the end of its life cycle, and now it's finished. And we move on to the next line in our code. Okay? So let's just say we have a counter, right, that we want to increment by 10 times, right? So we start at 0 and we increment by 10. Assuming we do this right, at the end of it, we should have counter equals to 100, right? Because we're adding it 10 times. Yeah. If we have this function called add10 here, realize all it's doing is saying, okay, take this variable here and let's just add 10 to it, right? So if I also console log out this at each step, after I do the first add 10, this will be what? And then the next one? Right, and so on and so forth, right? All the way until we reach 100. And the only reason why I want to do this is because I want to log out 10 times, and I'm calling this function 10 times. The way it's written here literally requires me to either type that function 10 times or at least copy and paste it, type it once and then copy and paste it 9 more times, right? Which is very inefficient, especially when you think about, in a lot of cases with computers, you could be asking a computer to do something thousands or millions of times. Clearly writing it out manually and going through it, line by line is not the most efficient solution. So there's this concept in programming called dry, right? When someone says your code is dry or not dry, what they really mean is don't repeat yourself, right? In the previous example here, this code is not dry because literally we're repeating this code block. We're writing it once because we have to, and then we're repeating it 9 more times. So because of how often we're repeating it, whenever you see a piece of code that's repeated over and over and over again, it means there's probably some way for us to abstract that away. And when I say that, it just means there's some way for us to represent this without having to type as much code, right? The other thing I just want to bring up here is that doing this is not technically wrong, right? The computer will execute this exactly the way that you want it to, and this will give you back the right answer. It's not wrong, it will execute. But it's also not efficient, and as we go forward, you'll see why doing it that way can actually be, it can not let you do what you actually meant to do down the road. Okay, so the first principle is always in programming, and not just for loops, but anything, right, is don't repeat yourself. If you find yourself writing the same code over and over again, it means stop, think, and there's probably some better way for you to do this more elegantly. Once again, we come back to our previous example, right? We have a counter variable, which is 0. We have our add10 function, which returns the number plus 10, okay? One of the things we could do is we could use a for loop, okay? Everyone's pretty familiar with the for loop at this point, right? I think it was part of the JavaScript Jumpstart program. Essentially what we're saying here is, all right, in a for loop, all we're saying is we have a counter, right? In this case, this is a variable I, right? Our condition that we want to say, great, should we keep going or not? Is this I less than 10? And when we're done with our function, we then say, great, how is I going to change? Okay. In this example here, let's say I take away this plus plus here. I just say I. What will happen with this function what will happen with this loop if I try to run it? Right, it would keep going infinite times, right? When I start off, it would be, what's I equal? I equals 0. Great. I keep going. Is I less than 10? Yes, because it's 0. And if I don't change I at all, I'll run add 10, I'll return I, and I'll keep asking you, is I less than 10? And it will perpetually be yes, because there's nothing that's going to change I, so that we're going to violate this condition at any given point. Similarly, what if I change this to say I is greater than 10, and I try running this loop? What will happen then? Yes.
Wouldn't run at all.
Why?
Because it's 0.
Right. In the very beginning, we would see, even for the first iteration of a loop, we have to check the condition, right? The first condition is, all right, we have our counter. It says 0. First condition, is I greater than 10? And the answer is going to be no. Okay, we're done, right? To a loop, that's all it does, is that it takes a statement and it evaluates it, and if it's true, it keeps going. If it's false, it stops, right? And this third clause here, this is what happens to this counter after whatever inside of here is finished running. Okay, so in this case, a very common convention is to say, well, let's increment this by 1, right? Because if we're looping over something, theoretically speaking, like, well, we probably want to go 1 by 1 down the list or down the object or down whatever it is that we're going down, right? But we don't have to do that. This could very well be I plus or equal 10. If we're trying to do every 10th variable, it could be I plus or 0. I plus or equal 2, right? If we're going down every other variable, this could be a lot of things. But in general, when you see this I plus plus, I just want you to know that it's what we do by convention, because usually we want to iterate over every item in a list, but that's not necessarily true. Also, the other thing to be careful about here, right? Actually, I'll come back to this, but realize here that we're declaring this variable I. And so I know on Monday's lecture we talked about, making sure that your variables are properly named, right? In this case, I think the exception we talked about was the fact that, all right, if in the cases we're using it for a counter in a loop, it's fine to keep it very short because we're only using this I variable within the confines of this loop. However, there is a hidden risk here with doing it like this, and I'll walk you through that later on in the lecture as to why sometimes even writing var I equals 0 like this can be very dangerous too. Okay, cool. So going back to what we want to do with this function originally, right? We wanted to call this add 10 function 10 times. Okay, and so here we have this variable that we start at I equals 0, and then we say is I less than 10, and then we add I, we run add 10, and eventually this will run 10 times. What if I change this to I less than or equal to 10?
11.
Why?
0 to 11.
Right, because the first condition we check is going to be 0, right? And then we do 1 to 1 all the way through 10, right? So that's going to be 1 through 10, which is 10, plus 0, which is going to be 11. And actually, where that's going to fail is on the 12th iteration when it tries to go through it. It says, okay, I equals 11, and then it will fail. So it's almost like saying like, because the index starts at 0, it's almost like how normally we think of numbers, we need to add 1. A common workaround for this is very easy. We could just say, hey, let's start I at 1, and let's do I is less or equal to 10, right? Perfectly valid JavaScript. We also do it that way. The reason why, typically speaking, in most loops that you see, we start at 0 is because when we go into other data forms, like arrays or strings, for example, right? The first character or the first item in a list, in most computer languages, is going to be an index 0, not an index 1. So if you want to go through every item in an array, usually speaking, you want to start at 0. And so that's why conventionally we see this start at 0, is because of that. But we could theoretically make this start at anything. We could make this condition anything as long as we're sure that at some point it will terminate. And then we could increment the counter or decrement it however we want. Any questions on this for loop here? Yes?
So instead of, if you wanted to increase I by like something other than just 1, like if you wanted to do like I plus 2, do you have to write I equals I plus 2 or is I plus 2?
Right, so what I actually do is, this actually just return I equals to this condition itself. So you can just do I plus 2, sorry, I should say. I would not do I. Oh, shoot. Sorry, this is what I'm thinking. In a for loop, it returns it right away in the statement. So I think it is I plus or equal to, but we can actually check that in the REPL very quickly. I think it's returned because I think it implicitly returns it for you, but we can definitely test that later on. Yeah, because I plus 2 is just going to be a statement. I'm not sure if it's going to evaluate and then return it, or if it's going to return it kind of in one go. Right. So that's how we do this in a for loop, right? With a while loop, it's the same exact concept, except now rather than saying, hey, do this many times until we reach this, we're kind of isolating it just to this middle part here, right? Like all we really care about is the condition, right? We're saying, okay, while I is less than 10, right? So we start off on a counter, which is I here. We set equal to 0, right? We say while I is less than 10, inside of this loop, we have to change I, right? Because if we don't change it, once again, if I is not changed, then this is true. It will keep running infinite times, right? So we have an I initially. We loop it over. We put in a while loop. We do I plus plus. We call this function, and now after we run this, it will go back to the beginning and say, great, does this condition still evaluate to true? And in this case, we start at 0. We're incrementing it by 1, so it still does. And then we evaluate this to 1 is less than 10, which is true. And we keep doing this over and over and over again until I becomes what? 10, right? Because when I becomes 10, we're going to go to this while loop. We're going to say, great, is 10 less than 10? The answer is no. So then at that point, we stop. So we're going to run it 10 times because we will run it 0 and then 1 through 9. So in both of these cases, both of these loops are doing exactly what we wanted it to do. And this is another core feature of programming that I'm sure you've already discovered, right? It's just that there are multiple ways for you to write code. And this is one of the reasons why we really encourage you guys to pair program, is just for this very reason, is because everyone writes codes very differently. And both ways, or several different ways, can be very viable and correct. And we want you to be aware of how other people think about code. It may not be the same as you, but it could work and get you the same exact answer.
So what if you could use the while code or the for? Which one's better? Is there certain situations where one's better than the other?
Yeah, totally. So there are definitely a few ways in which like different use cases, right? So in general speaking, for the vast majority of use cases, these are very interchangeable. I would say that in general, I see for loops more often. I see while loops more for situations in which you don't actually know when you're going to stop, and it's something you just wanted to keep doing while something is happening. Because in a for loop, because you're incrementing it usually by a constant amount, you kind of say, I want you to do it X many times. Whereas for a while loop, it's like, like, hey, I want you to do this until something hits false, right? So in the real world context, this is a little bit outside the use of a loop in this like specific like kind of iteration phase. But let's say I want you to say, hey, can you get some data from Facebook for me? And I want you to keep doing it until you get this data, right? If Facebook says, API is down, keep doing it over and over and over again until I get my data, and then you can stop, right? So that's an example where within for loop, I guess we could write something really weird to increment this counter so that like it does reach a certain point and then we stop. But usually, just like from like a visual perspective, when you do a while loop for something like keep doing this until something that I don't know what's going to happen, but it should happen, is met, that's when a while loop usually is kind of used more commonly. But I think in the wild, I usually see for loops way more often.
I have a question.
Yes.
So in the for loop, you have the variable I. Is there an example of when you wouldn't declare a variable? You wouldn't have a variable that would just be I equals 0 or something like that, or
You wouldn't declare it. Okay, so well, so if I took this away, right? If I took away the var, right? I just say I equals 0. That almost assumes that I exist somewhere else. Like I've declared I somewhere else. And if I haven't, it depends on kind of which iteration of how the JavaScript is implemented in the browser or IE. But one of two things will happen, right? It'll either create this global I on the window for you, which you don't want, and we'll talk about why global variables are really bad later on, or it'll throw an error saying I doesn't exist, right? It's because you're calling this variable that you haven't declared yet. Is that kind of getting to your question, or did you have or you're going somewhere else with that question?
think that's so. There's always going to be a variable there.
Right. This is always going to be something here, right? So if I if I do it here and say var I equals 0, I could easily do like I equals 1 here, right, and do it like that. But usually speaking, this counter is used only for this for loop, so we kind of declare it as we're using it. Cool. Yeah. So both the for loop and the while loop works very similar in that basically, if the condition is true, it means do whatever's in your loop. If it's false, that means stop, I'm done, right? It can be true many, many, many times, but as soon as it hits false, it terminates and we don't go back to it. That's the most important part. So, okay, cool. All right, so looking at the construct of a while loop here, right? While is what we call a reserved keyword in JavaScript. And really every language has reserved keywords, right? It's the reason why you can't have a variable called for. Okay, it's a reason why you can't have a variable called while, right? Is because there are some like words that JavaScript says, all right, don't mess with this. This is like you need this to run JavaScript, so like don't do anything weird with it, right? So that's what we say reserved keyword. It just means, don't have a variable called var while, right, or var for. Okay. Condition to evaluate. So this is something that will evaluate to either a true or a false. We then do our curly braces from earlier. We indent the code so that we know that everything that's indented here is going to be executed inside of this while loop, right? Okay. And then if we were to look at this code block up here, right, we start with this var number equals 1, okay? So one of the reasons why we're declaring this outside of this while variable is because inside of here, right, this is a condition, right? We can't say var number less than equal to 4, right? Like JavaScript probably will throw an error if you do that. It'll say, well, you're declaring something but evaluating it at the same time, and you're doing it over and over again. Like that just does not compute, right? So that's why we're declaring this var number out here, and then we just toss it in here right away, right? We're saying var number, we start at 1. Var number, while number is less than or equal to 4, let's do whatever it is that we got to do. And let's just log it out, okay? So, and then, yeah, there's a curly brace there. Okay, cool. So in this loop, all we're doing is logging the number, and then we're incrementing number, right? If we don't increment this loop will just go until infinity, right? It will throw an error at some point, right? But here, when we do this, is number less than or equal to 4? Yes, so let's do this. We're going to get number 1, and then we're going to, number and output are the same, okay, because we're logging number out, right? But essentially is we log out number 1, we increment numbers, so now number is going to be 2, and we evaluate it, is this true or not, right? Is 2 less than or equal to 4? It is. We output 2. We do the same with 3. We do the same with 4. And then after 4, we're going to increment number 1 more time to 5. And then 5 will be false. So then we don't have an output because at this point, when this becomes false, we jump down to line, theoretically, 7. If it existed, right? Like, we don't go through all this again. We're just straight up done with it. Okay. Does this like convention, does this style make sense for everyone? How while loop works? Okay. So to contrast that with like the I guess syntax for a for loop, right? It's for loop usually as we use it when we say, I know I want to do it X number of times. Now that X number of times doesn't have to always be constant, right? Because if you say, I want you to print out, every letter in a word, it doesn't always have to be the same word every time, right? But that number has to be fixed, or that number should be fixed when you're using a for loop. Usually, okay. So how the syntax of a for loop looks is we now, rather than having a declared variable in the very first line, we're just going to declare it here, initialize it here. We still have our condition of true or false, and then we have our update. How are we going to change that counter over time? Once again, for, do not use that. Do not have a variable called for. JavaScript will not let you, or if it does, you don't want to know what happens afterwards. We have the expression with the condition, and then we have the changes. So really, I mean, in essence, like this looks almost identical to the while loop, right? Except we just kind of move some of the things around. But the concept is still the same, right? We need to have an initializing counter. We need to have a condition, and we need to be able to do something to the counter at some point inside of the loop. Yeah, and then lastly is these are semicolons. Basically to tell JavaScript when it reads through this, like, great, like where are you? Where does the initialization end, and also where does the condition end? And it basically assumes where the update ends based on the closing parentheses, right? So in every JavaScript loop, you need to have those two semicolons because otherwise JavaScript doesn't know like, or else JavaScript wouldn't know kind of where each of those three things like are. So when you look at the same, or I guess not same, but very similar problem, right? We're doing the same exact thing, except now we're going from 1 to 5 rather than 1 to 4. And if we look at this logic, it's literally the same exact thing, right? We start at I equals 1 here. Is that true? Yes. Great. Let's log it out. Let's and then we're going to increment I, right? This happens after we do the function. We're going to increment I, and now let's go back here to the beginning again and say 2, true, 2, and on till we get to 5. And then at 5, we're going to increment it still because, you know, this loop's not done until we do this increment update, right? And then we go to the next iteration and we say, great, is 6 less than or equal to 5? No. And then at that point, the for loop stops and we move on to line 4 in the code. Okay. So looping over every individual character in a string. Oops. So if you think about a string, right, like strings are actually very, there's a lot of complexity in a string in JavaScript. So like, I guess like, I'll show you like how we use it on a very basic level today. But if you are playing with strings, like there are some things that may seem weird to you, that it's because of the way strings work in JavaScript. I guess what I'm trying to say here is just that like strings are very special creatures, and when you use it, like it may not always work the way that you think it does. So if I want to loop over a string, right? If I want to say, hey, you know, print out the cheeseburger or print out every letter in this word for me, right? How do I do it? I guess we just do this one. I think this is a pretty good job of doing the code, right? Well, how do we access, you know, a character in a string? We have two ways, right? We can either use bracket notation, which is basically saying, all right, give me the word. Okay, in this case it's burger, or the variable is called burger, right? And give me the character at the 0th index of it, right? And this 0th index is the first letter, which is usually why for most for loops we start at 0, right? Because usually when we're iterating over, you know, a list or a string or something, like the first item is always at index 0, so we want to kind of keep that consistent. So we're saying, okay, for this string, let me first figure out how many characters are in the string. So I'm just kind of skipping this a little bit, right? But so we have our string called burger. We know how to get a letter at a certain index, and now we're just saying is how many characters are in the string. And I think in this case we say 12. So we say, okay, great, log for me 0, 1, all the way down through 12, right? Obviously this code is not dry because we're doing literally the same thing minus 1 change 13 times actually. So clearly there's some more efficiencies we gain from using a loop. But once again, this works. This is correct JavaScript. This will run correctly wherever you're running it, and it will give you the output that you want. And here's how it looks. You know, the previous code was 13 lines. Here's how it looks. Actually, no, yeah, it was 15 lines if you include the declaration. But essentially here now, we're doing the same exact thing, except now we're using a for loop, right? So I say, yeah, so here, we initialize it. We say, okay, if we're printing out every letter in the string, we're going to start at 0 because that's where the index is, right? So let's start at 0. And then we're going to say, while this number is less than index.length. So here's an example, right, where burger.length is going to be a fixed number. In this case, it's going to be 13. Yes. No, 14. Yeah, 14. Yeah. So in this case, it will be 14. But I think the really tricky part here is we want to be, actually no, 13 or 13. Yeah, sorry. 13. Yeah. So, but the tricky thing here is burger.length, right? This is going to be a fixed number when we run this code, right? But I can very easily here say burger equals, you know, food, right? Which is 3 letters long, and now I run it. This will be 3, right? So this is an example in which like this value needs to be fixed. But we can change this however we want before it gets there. if that makes sense, right? So in this case, I'm saying burger equals this string called cheeseburger, right? But I could very easily point this to something else I could change so that when it gets here, I don't know for sure what this number is going to be when I get here. But all I know is that once I start this loop, I will have a fixed number here. And if I don't, JavaScript will give you an error saying this needs to be a number. Or dot length, this thing needs to have a dot length property. Does that make sense? So once again, we use for loops to do things a fixed number of times over an element. This number has to be fixed when we run the loop, but what it's dependent on can be flexible either before or even after the fact. And in this case, we're just saying, okay, while this index is less than the length of the word, right? Because obviously, if I print out every letter in the word, I'm going to stop once I hit however long I think the word is. There should be no more letters after that. And then once again, here index, I'm doing a plus plus because once again, I'm just iterating over every letter in the word, and I save about maybe like 10 lines of code there. Does it make sense, everyone? I know this is very basic, but this is also something that like we harp on so much is because there's not going to be anything you do going forward that's not going to require some kind of loops. So it's really important that like everyone's crystal clear on how loops work. Okay, so here's something that you may have assumed from earlier, but just to kind of make a point of it. When I declare var I equals 0, right, and I increment it, right, inside of this loop now, what this is really saying is, hey, create this variable called I and use it, right? If we look on the previous slide here, we created a variable called index, right? That's our counter by default. But we're actually also using that counter as well, right? To say, access for me the 6th letter in burger, or the 13th or the 12th letter in burger, or the 13th letter in burger, etc. We're actually like using that variable inside of our loop. So in this case here, you know, it's very, very easy for us to do this. In this case, you might think like, oh, well, you know, why is this not 10, right? Because why is this 55 and not 10? Because, you know, we're going to I equals 0 all the way to I is less or equal to 10, right? So we should stop at 10 and sum plus or equal I, which is going to be 10. But what we're actually doing is we're actually adding up every single number between 1 through 10, right? So sum starts at 0 here, and we're doing 0 plus 1, which is going to be 1. And then we're going to do 1 plus, sorry, the first one is going to be 0 plus 0, but this is going to be 0 plus 1, and then it's going to be 1 plus 2, and then whatever 1 plus 2 equals, plus 3, and so on and so forth. And so this may not seem like much, but in actuality we're going to get 55 because we're actually adding the variable of I each time. Okay. Last note on loops is, okay, let's say I'm in the loop, right? The condition, when the condition evaluates to false, the loop is going to stop. And you know, usually speaking, like I know that ahead of time, right? Like I'm okay with that. But what if there's a case in which I either want to break out of this loop entirely, or at least skip over the rest of the iteration of this loop? How do I do that? And so there are two more terms here, and these are all reserved words in JavaScript, which means no var continue, no var break, all right? Like don't use those as variable names. Break says, all right, end the entire loop, right? If I have a for loop that goes from lines 1 through 3, break basically says, stop what you're doing right now, go to line 4 of the code. We're done with this loop. We're just straight up done with it, all right? Nothing else. Continue says, let's skip the current iteration of the loop, and then let's go to the next iteration of the loop. So what that means is saying, okay, don't execute all the code in between the curly braces. Let's skip that. But let's update, you know, our counter, and let's check the condition again for the next instance, right? And so these two terms really give you a lot more flexibility in trying to figure out your code. You know, do you want to keep doing something, or do you want it to, you know, maybe behave a little bit differently? It's not uncommon in a for loop, especially to have like a, you know, if I'm making a bunch of requests to an API or to a server somewhere, it says, you know, give me this data, if something says, like let's say my first line is give me this data, and my next line is save this data to here, it makes sense for me to have a check, right, in line 3 that says, hey, give me this data. If data is empty or if data says error, let's skip the rest of the code, right? Because it's definitely not gonna apply, right? And in fact, if I keep running it and the data's not there, it's gonna throw an error anyway. So it's almost like a way for me to proactively say, all right, there are certain instances in which I know I don't want to keep going on with the rest of this loop. Let me skip it, and that's what break or continue wants you to do. Return is something that you've definitely used before, but return is actually extremely powerful. And so when you use return, what that does is it not only exits the loop, it actually executes a function that the loop is in as well. And so when you work on some of the workshops tonight, you'll start seeing how this kind of scope kind of creeps in, right? Where once you return something, you're not just saying, hey, I'm done with the loop. You're actually saying, I'm done with the loop and the function that the loop is in. So during the workshop, you'll see examples, but just be very careful of like when you return something, it's not just breaking out the loop by itself, right? It breaks out, it ends the function that it's in as well. Does everyone understand that, or does that make sense, everyone? Or anyone just want to see it drawn on the board?
Are we
Okay,
going
cool.
to break and continue tonight?
Yes.
Can you go over continue again?
Sure. Continue, right? So sure. I'm trying to think of like a real world example that makes sense for this, right? Like let's say I have like 10 servers I need to get data from. Like I want to get 10 pieces of data, right? And I go to the first one, and I get it, right? It says, okay, great, you have this data. I'm like, great, save it to my own database, right? I do it for the first 3. On the 4th one, it says, oh, no data is available, or somehow I couldn't get this data. Well, I don't want to just stop, right? Because I want to keep going. I want to get the 5th through 10th piece of data still. So I'll say, all right, continue. As in, skip saving this data because it doesn't exist right now, and let's just go on to the next one, the 5th piece of data, and then 6th and 7th and 8th and so on. So continue. If I have like a multi-loop function, so yeah, let's just use this example. Now, this is a bad example because there's only one line in the function here. But yeah, if I have like a if check here, right? If I say if var I equals 7, for example, right? Continue. It means that I'm gonna add every number to this sum except for 7. Right? Because if assume the if check happens here, like right before the sum plus or equals I, right? The continue basically means if a certain condition is met, let's just skip the rest of the code in this for loop block. Let's just update our counter, and let's just go to the next iteration of this code. Right? What?
What does break do? Break does break.
Yeah. So for break then, what it would do is it actually wouldn't even go to the next iteration. It just jumps down here. It finishes, it just stops the loop entirely. It doesn't go to the next iteration of the loop. It just stops entirely. Right?
What does that look like when you write it out?
Sure. Yeah. Let's just do a quick example of this because this is actually pretty important. Okay. So let's just say we have a for loop here, right? And we have var I equals 0. I less than 3, we'll say, and then I plus plus. Okay, and let's say this is my console log on this side. Okay. And then I have let's say I have an if statement here, right? That says, okay, if I is equal to 1, I'll do something. Otherwise, I'm going to console log I. All right. Does this make sense so far? Like with this very simple function, right? Very simple loop. Can we see this? Okay. So if I don't have this at all, right? This isn't there, right? What is it going to console log when I run this?
Isn't there? Yeah.
What happens when I run this loop right here?
Every I will be 1.
So what's the output on my console log? 0, 1, 2. Okay? So I'll say, so this is going to be a little bit tricky, right? So I'll say empty, as in no break or no continues, right? The log is going to be, it's going to log out 0, 1, and 2. Okay? Great. Now, if I say, okay, if var, and obviously my indentation is terrible. Oh, no var. Okay, if I is equal to 1, continue. What is that going to console log? 0 and 2, right? It's going to go to 0. Is this true? No. Okay, I'm going to skip this if loop. I'm going to log out 0. And then 0 is going to be incremented by 1, right? We're going to say, okay, great. Is 1 less than 3? Yeah, let's keep going the rest of the loop. Is 1 equal to 1? Yes. Continue. Okay, great. So let's go to the next iteration, right? Let's increment 1 by 1. We can now get 2. Is 2 less than 3? Yes. Is 2 equal to 1? No. So we skip this if loop. And then we log out I 2. We increment it again. I is now going to be equal to 3. And we're going to break this condition. So now we're done with the loop. Okay? Does everyone know how we got to continue? No? Yes? Okay, cool. All right. For a break, then, what are we going to get a console log here if I change this continue here to a break? Right. It's going to log 0, right? I started at 0. Is 0 less than 3? Yes. Is 0 equal to 1? No. So I skip this and I console log out 0. Right? Very straightforward. I increment 0 by 1. 1 is 1 less than 3? Yes. Is 1 equal to 1? Yes. Break. Great. I'm done. I'm not going to check 2 anymore because I'm done with this loop at this point. Like, I'm completely finished. I'm not going to check any other future iterations, but I'm breaking out this entirely.
Isn't this very similar to return though?
So the reason why return is different is because, well, so for one thing, return actually returns a value, which you may not always want to do, right? But the other thing that also happens is, how do I do this without messing? Whatever, I'll just rewrite this. So yeah, I guess we'll just cover the why return. What I mean when I say return breaks out the function as well, right? So let's just say I have this thing here, right? I say, okay, var foo equals function of okay. So I have this function here now, right? And then inside of this, I'll have a for loop. I'll say for var I equals 0, I is less than or I is less than 3, and then I plus plus. And then I'll have my old console log here. I'll end this here. I'll say I have a console log here of I. And then here, I'll actually also have another console log of, give me a word, someone. Wednesday? That's pretty long. I'll say wed. Cool. Okay. Let's say this is my code, right? And down here, I invoke it. I say, great, foo, start running. Okay. So assuming it's empty still, right? What's going to happen here? What are the console outputs going to be? What else? Right. Wed's also going to be logged, right? It's a function. I execute this. I go through the loop. And I have one more line down here that I still need to execute, right? Because this is a function. I know this is terrible curly brackets, but just imagine this is the closing bracket. This is the opening one. Everything here is inside this function. I have to execute all this code. I don't just stop with the first loop and I just finish, right? So the output is going to be 0, 1, 2, and then I'm also going to log out when. Okay, does that make sense, everyone? Okay. Now let's say I go back to my old condition here, right? I'll say if I is equals to 1, and then I do continue. what's the output going to be? Zero to what, right? I skip the 1, but when I'm at 0, I log it out. When I'm at 1, I skip this iteration. I go to I equals 2. I log that out, right? I'm done with the loop, but I'm not done with my function. So my function keeps running, right? And then I go and I log out what down here. What happens when I do break? Sorry, what is it? 0, and I go straight to 1 now, right? Because I don't finish the rest of my loop. And now, let's just say I do return. What happens here? I have 0, right? Because 0 is not going to change, right? 0 is still going to run perfectly fine like it normally did. And then what happens?
You hit the if statement return, and then it returns out of the whole thing, skips the console log until the skips to the end of the function.
Right. This basically return, like, break says stop right here, right? This is my loop, stop here. Return says, oh, this is a function I'm in, stop there. And so now this is why the output for each one is different. And that's why the break and the return, if you're looking at it only in the confines of the loop, it does the same exact thing outside the fact that returns a value. But when you're putting in a bigger function, break and return do skip different parts of the code.
Is this a matter of scope? Is that what you're kind of talking about here? Or
Yes,
local versus
Yes. Yeah, so basically return is going to return out the nearest function scope is how like you would say it. Yeah, return returns out your nearest function scope. Yeah, so that's yes.
So like break stops within the function, but then return stops within like the whole thing. Sort of?
Return exits out of the function. Break exits out of the loop.
That's what I meant.
Yeah. Cool. All right. Yes. Yeah.
For the return, do you have to pass it something, or you can just put return, like you don't have to do return I?
Yeah, I've actually seen you can just return it and it'll just like not pass. It'll pass like a null or something to it. So you can just return it to just get out of this loop as fast as you can, or get out of this function as fast as you can. But obviously you could always do like a return 6 here, right? It'll just pop 6 back to whoever called it. Right. So actually to answer your question there, right? Let's say I wanted to do a console log of foo. Oh, actually, yeah, that's fine. So here, when I call foo, right? Rather than just calling foo, I want to console log foo. And I'm doing a return 6 here. This will be the same. No, wait, sorry, that's not right at all. Hold up. Okay, so if I was to do console log foo, for example, right? I'll just erase everything. Wish I had Control Z in real life. Use the copy and paste code again. If I was to do this in real life, right? This code executes. I console log out 0, 1, 2, right? And then I console log out what? And then I console log out whatever this function is returning. But what is it returning? So what in JavaScript happens? What do all functions, and actually this might not be something you've covered yet, but what do all functions return implicitly? Like by default, what do all functions return? Undefined, exactly. So if I was to do this, I wonder if it will actually work. I'm not sure if undefined will actually console log. But just bear with me here for illustrative purposes here. Let's just say this is going to get back an undefined. Right? Because I'm console logging something else like out again here, right? If, however, I was to say if I is equal to 1, return 6, then in this case it will be 0, and then beneath it it will eventually say 6, because I'm returning a 6 that gets console logged. And then if I assume I go with the same example, there will be undefined here as well, and also a 1 here as well. Does it kind of make sense to everyone? What's happening? A lot of arrows, a lot of conditions. Hopefully it makes sense. If it doesn't, it will have to eventually for you. All right, cool. So this is why also, and this is why, I mean, this code is a terrible example of proper indentation, but this is also why scope is so important, right? Because now we see that there are certain things that only do things in a function scope. There are things that only do things in a what we call a loop scope, or more commonly called a block scope. Okay, so if you write code that's poorly indented and someone says, oh, well, this indentation ends here, this must be part of the loop, and it's not as part of the function, like that could cause unintended consequences, I guess, right? JavaScript will read this code and interpret it very, very literally, right? So always be sure indentation. It's helpful not just for making it look pretty, but sometimes it also does matter for how the code's gonna execute too. Okay, cool. Everyone clear on these three concepts here? Continue, break, and return. Cool. Oh, the suspense is killing me. Okay, so let's think the things we can loop over, right? You can loop over strings, right? Because each character has an index. We can loop over that. You can loop over an array, right? Because each element has an index in this list. You can actually loop over objects too, and we'll talk a little bit more about what that looks like once we kind of cover objects more in depth. But they're also, what we call them is iterable, but not numbers, right? Because a number is not like, when I look at number 3, it's not 1, 2, 3, right? It's just 3. Like there's nothing to iterate over. So like same as how you can't iterate over a Boolean, right? Like some things are just like a constant value, and so when you see like a for loop over something, like usually when we're saying like, hey, let's iterate over something, it usually means, hey, let's do something for every element in this thing. And really just as a general rule of thumb for you guys, especially like kind of in the first 2 weeks of bootcamp, just kind of remember that strings and arrays are going to be the vast majority of the things that you're going to be iterating over. Okay, objects are special, and we'll cover those later on, but strings and arrays are going to be like 99 if not 100% of the things that you iterate over, right? So if you have a Boolean, don't bother iterating over it. It's not going to work. Okay, so that covers loops. Are there any other questions overall on how loops work? Okay, the next part is really simple. I know everyone wants a break probably, but it's just one slide, and it's just and or. That's it. So what does and or mean? They're what we call logical operators, and like that's a lot of words to be quite honest. I'll erase this for now. Just diagram on the board, kind of a very hopefully simple way to say what and or is. All right, so basically and or are exactly what they sound like, right? They basically evaluate two conditions, right? And they will tell you if. Okay, so I think the way that most textbooks have a diagram of this, like, hey, let's have t equal true, right, and false equals false, or f equals false. So it's like the and in JavaScript, the and looks like. I mean, not this, but this, right? And then the or looks like 2 bars, or 2 pipes, as we call them. So that's what the and or textbook looks like, right? So let's say true becomes, we'll say uppercase T, and then false becomes uppercase F, right? Let's go through a few examples of what this looks like, right? So let's do T. Do you guys mind if I just use this instead? Because it was way too ugly. So this is and, okay? T and T, F and T, and then F and F, and then T and F. All right, what's all these going to give me? Start at the top. Okay, so give me a true. What's this?
False.
false, right? Because, well, false basically says, so basically what this and is saying is, this side has to be true. And this side also has to be true, right? In this case, we're not saying if they're the same, right? We're saying, are both of them true? And if one of them is false, then it honestly it doesn't really matter what the other side is, right? It's gonna give us false anyway. Cool. So this is how and or works in Booleans, right? And so reading this text, let's just skip this part for the next like 30 seconds. Pretend you haven't read this second half yet, right? This is first part. Logical operators are usually used with Booleans when they return a Boolean value, right? So we say true and true is true, false and true is false, false and false is false, and true and false is false, right? So this is how and works with Booleans, right? So let's turn all of these now into ors. All right, what's this first one? Cool. Right? As long as you have one true in there, doesn't matter which side, doesn't matter what the other one is. Like with something like this, the first one gives me all I need, right? I don't even need to look at this thing variable. It doesn't matter to me anymore. So this is how true and falses work with and ors, right? The thing that's a little bit confusing is, and this is something like I don't want you to get too hung up on because generally speaking, when you see these conditions, usually they will be used with true and false. Okay, but let's say I have something like let's say I have something like this. What would this give me? If I console log out this, what would it show my console log? Earlier we were console logging out that and it gave us true and false, we'll say, right? Undefined. Did you say there's a good undefined? You say true, Mac? True. Yo, is that you, Alex? You said no? Yeah, these are strings. Two no strings.
Okay.
What does that give me? Right. So the answer is they're going to give me a no string. And the reason why this is really tricky to think about is JavaScript also has this concept of things that are falsy. Okay. So something like null is falsy. Something like 0 is falsy, right? And so like in this case, the second half of this paragraph is saying when they're used with things that are not Booleans, they actually return like whatever the value is, unless it's falsy. Yes, unless it's falsy. So in this case, and I guess the ironic thing about this first clause is that I think JavaScript looks at this in sequence. So when we say no here, and no it's evaluating, we can make this a yes. And then what do you think that this would be now? Right, it would still be a no, right? Because JavaScript is smart to say that, okay, this first thing, is it like a truthy thing? Yes. Great, that's all I need. Like, I'm going to print that out. I don't even need to look at the next thing, right? Because nothing it could possibly be is going to impact my decision on the fact that this is going to be this is going to evaluate to truthy. And when it's truthy, it returns a variable. It returns the element. Yes?
Why is the no string a truthy and not a falsy?
Right, because a string literally is just a string. The only string that's falsely is an empty string. And that's also something that's very tricky because that's not the case in all languages. This is why programming is like. Have you guys seen that like XKCD cartoon of like this cartoon guy who's like, there are 12 different standards for this. I need to make up one that ties everything together. and then he works really hard on something, and then like a month later, it's like now there are 13 standards for this thing, right? It's like everyone just kind of iterates over the same thing over and over again, and like different versions of the same concept pop up. So like an empty string, and honestly, for you guys, anything I'm saying here, you can totally check me by just going to Chrome and just going on console and printing this stuff out. Like this is how JavaScript should be implemented. If it's not, then we can talk about it. But like really like in this case, so once again, like in generally speaking, you're gonna be using Boolean values when you use and or operators. In the cases that when you don't, they actually just return the variable itself, right? So what I mean by that is, let's say this is 0. That's a 0. Then what does this become? It becomes yes. Because this is going to return the last thing that it ought to be true, which is a string with content. Right, 0 is falsy, right? So I'm just going to skip this, right? Because I know, okay, this first clause didn't meet my condition. Let's go to the next one. Does that meet my condition? Yes. Or, sorry, that used something. But yes, it does meet my condition because it's a string called yes. So it's truthy, and I'll return it to you. Yes?
So when you do two falsy statements in an OR, when I'm doing it, it's just giving me the second statement every time.
When you do a falsy statement.
Like I did 0 or an empty string, and it
Check.
gives you like a second one back.
Double check on me on the empty string. Is that considered falsy in JavaScript? I just want to make sure like I got that part right. That's the one that always
Right.
happens. That's
No
considered
is
falsy?
a falsy, right?
What?
No is a falsy.
No.
No.
No is false.
No.
No is falsy
No
because
or
no is something that's defined but not something that's declared but not.
You said no, so it should be a falsy, right? You said no or no gives you a no. So that means no is
Not a string now.
No is just a string. I should not have used no or yes. Let me just replace like the word no with like any other word in the language. Like Wednesday. Wednesday or Wednesday is gonna give me Wednesday. Okay. 0 or Wednesday is gonna give me Wednesday. And then Jim, I think sorry, are you checking the other thing too?
Yeah, I'm just seeing like null and 0, and I switched them around. Always the second
It
statement.
always gives the second statement if they're both false.
Okay, it always gives a second statement, they're both false.
It checks the first statement, if that's falsy, then it automatically, no matter
Oh, no, I'll return to the next one. Okay. All right, because it's always going to be giving. It's all right because once the first one is made a condition, there's no criteria for the second one that's going to change anything else except giving it back to you what it was. You're right. Sorry. So what we're talking about here, right, is that basically like if I'm JavaScript, right, if I'm the program running JavaScript, and I say, all right, basically all it's really doing when it looks at non-Boolean values, that it's basically saying, okay, which value should I give back to you, right? It's either going to be the first one or the second one for non-Boolean values, right? If the first one is null, is falsy, I'm definitely not going to give that back to you. So it doesn't matter what the second one is. I'm going to give the second one back to you. If the first one is truthy, I'm just going to give that back to you because I don't even care what the second one is either. So that's the way you should be thinking about this.
So empty and says empty string is falsy.
Empty string is falsy. Okay.
So is null, so is undefined.
Okay. Yeah. Google JavaScript falsy. There's like a ton of references for it. For like what is considered falsy. It's one of those things that I think after a while you just kind of intuitively get a good sense of what it is. But there are like definitions for it. I think in Python, I think it's true, if I remember correctly. But yeah, that's why computers are not fun.
So I thought or was like one of the conditions has to be true,
Right.
but that kind of says not really, because if the first one's not true, then even if the second one's false, it still will produce the second one.
Right, for non-Boolean values.
Oh.
Right. Booleans are. This is like one of those things where like it's like a rabbit hole. The deeper you go in there, you see all these edge cases. Like you will almost always only use Booleans for operators. If you don't and use other variables, just kind of have a good sense of how it should be working. But usually, like people use those just to check Booleans, right? Like I can think of scenarios in which I would use this, but for the most part, don't worry too much about it. It's actually like a very not common, but it is a convention I've seen, right? Where like let's say I want to pull data, right? And I have like six I want to pull this. If I don't have it, use this. If I don't have that, use this, and so on and so forth. So you just chain them up in one big OR statement, and then you just go down the list, and whatever gets true first will just get returned. So that is like a valuable way to use like and or in a non-Boolean fashion. But I would say for now, I think you're pretty good with this, with using and ors primarily for Boolean values, right? 0, and the other thing to know about Boolean values is that 0 is falsy, right? So 0 is going to give you a falsy number. Every other number is going to give you true. I think even negative numbers, I believe. Someone can check me on that too. But yeah. So this is one of those things that it's confusing, but the bright side of it is this is also something that's super easy to check if you're ever unsure about what it is, right? You go into Chrome and you just console log out anything you want. It should just be a quick copy and paste, right? So that's always the best way to make sure. If you want to understand it, obviously you just do a bit of thinking, but if you want to test out something you're doing, super simple, super simple.
Yeah, any number and any negative number is true.
Okay, great. So 0 is the only falsy number we have. Oh, cool. All right, so that was it for the lecture and the slides. Are there any questions on anything we've covered tonight before I open up the workshops? I'll wait a bit longer because I don't know.
Just to recap what you covered, the for loop and the while loop both can be used and do the same produce the same kind of results, just kind of preference. There is times where it's better to use one or the other.
Yeah.
But we didn't really cover when those times are existent.
Yeah, so in the slide I think it had this kind of like one-liner that was, it kind of hinted at it a little bit, but once again with computers, with like especially with programming stuff, is like there are some things that are like there are several ways to do the same thing, right? So I would say as a good rule of thumb is like if you're going to iterate over something a fixed number of times, it's usually good to use a for loop, right? If you're going to do something until something else happens that you're not sure of,
like a break or a condition or something like that.
It will have to be a condition usually. Yeah, if you're going to do something that you don't know how long it will take, right? So like let's just say this. Let's say, okay, yeah. So this is an example. Okay, so there is a workaround for this, but just bear with me for like the hopefully like the essence of what I'm trying to say here, right? I want you to keep rolling a die until you get a 6. How many times would it take you to do that? I could get 7 once easily.
One die and you need a 6.
I roll it. I rolled out. I could roll that die 7 times in a row and get 1s every time, which happens in Vegas, right? So for something like that, just like intuitively thinking about it, it's like a while loop would probably be the better way for that because like it could happen, but I have no idea how long it's gonna take me to do it, right? But if I say, hey, print out for me every letter in a string, it's like okay, I know exactly how long the string's gonna be, so I'm just gonna iterate over this 1 over 1 until I get to the very end of it. So that's like conceptually how you should be thinking about it. The only reason why it's not is because theoretically speaking, if you roll a 6, you could change the counter in the for loop and then it would break the condition, but then you're just making life really hard on yourself for no apparent reason. And I just don't do that in programming. It's gonna be hard enough. Usually it's hard enough. Yes?
Maybe more trivial, but you always, I saw that every time you use if-else statement, you never actually put else. Do you not need to put an else statement if you use an if statement?
Okay, yeah, so that's a great question. So that's the case. So I think in that example I was showing you earlier, right, was I had an if and there was one line behind it, right? Let's say there was 2 lines beneath that. And I want to make sure the second line always executes. Right? So let's just do a really quick example here, right? So I'm going to write pseudocode again, right? Which is basically just, let's say I have a function here, right? I have a for loop here, and then I do the same thing of declare a global variable here. Bad, don't do it. Okay, and let's say I have a this is my loop start, this is my loop end, this is my function end, right? If I have like a if I'll say I is, how do I check if a number is even? how would it actually look? I modulus what? 2 equals 0. This is an even number, you're saying, right? Okay, cool. So I'll console log out even. I'll just write console, okay? I'll write console for now to make it. I'll console log this is even, right? And then if I want it to be odd, in this case, I could just say, actually, hold on. Okay, yeah. So if I just write console log, let me spell console. Console log odd, this is even, it's a string, right? And I console log out odd. What's going to happen when I roll an odd number here? Right, and what's going to console log out? Odd. If I roll an even number, what's going to happen? It will print even, and then it will print odd right afterwards, right? Because it keeps going. So in this case, an else statement would be very, very useful for me, right? Because I only wanted to do one or the other. But if I change this to be a string that says, successful row, right? I want that to run no matter what happens, right? So if I just say a success here, I want this to print no matter what happens. Well, in that case, there is no else clause, right? The else clause is just going to be empty. So in that case, I can just make do with just this. So what I was doing earlier was like, there was something that I only wanted to happen if it was true, and there was kind of no else condition, or no else thing to do. So that was why I just skipped the else. But in some cases, you definitely need an if or an else. Yeah, but yeah, okay, yeah, maybe that was a rude question, is you don't always need an else with an if statement. That's not necessary. Cool, see, that was 2 more questions. I think I waited for 20 seconds. Any others? Yes?
So in a for loop, you can assign the variable either before it or within it. And then for a while loop, generally you assign the variable before.
For a while loop, you have to assign it before because you can't declare and check condition at the same time. In a for loop, you could also just do a var I here, I believe, equals 0, and then I equals 0 like that. I think you do it there too. I think the reason why people don't encourage you to do it is, once again, this is something that you only want to use as a counter. You don't want to kind of instantiate it at a place where you don't need it yet. So the other thing I was going to show you guys about why it's dangerous to use var, and you'll eventually, I think during the last week, we'll talk about what are some ways around this, right? Is that if I have a for loop up here, right, and I console log out I down here outside the for loop. Console log out I. That's not right either. What's going to happen? So 1 guess for 2. Any other guesses? Sorry, for loop, opening bracket, closing bracket, random console log in the middle. I'm sorry? Undefined, someone said?
Yeah.
3, 0, undefined 2. Okay, great. We've covered almost everything possible that's 3 or less. Any nulls? False, truths? Cool, let's just try it. By the way, does everyone uses REPL, right? Okay, if you don't, it's really great tool for just like testing things, really quickly, right? So I have a for loop. Oh God. Okay, cool. So for, oh man, this is okay. So I have for I equals 0, right? And then I have I is less than 3. I do I plus plus. Whatever, doesn't matter to me. And I have console.log out for me I. It's going to give me 3, right? And the reason why this gives me 3, so 2 things, right? One is, why do I have access to this I even though I'm outside of this loop?
It's still in the same scope,
Right.
whatever that
Exactly. When I use I, what it really does is creates this var I that's now available to everything in the function scope, right? And so this is technically still the function scope. So now, even though I'm technically outside of my loop, this I still exists, right? And so this is why it's a little bit dangerous sometimes because like usually people look like, oh, like I created this counter that's only in my little like for loop scope. Great, this I doesn't exist anywhere else. Like no, it's on your page still. You just don't see it, and you probably will redeclare it if you ever use another loop for it. So maybe this is a good reason for why you should always redeclare your counters just to make sure it is always what you think it is, in case someone else didn't use it in the code base, in the function or in the page ahead of you. The other reason is why is it 3? Because when this fails, this doesn't fail on, let's say y is on 2, right? If this doesn't fail on 2 is less than 3. It keeps going. It only fails on 3 is less than 3. So at that point, that's when I stops iterating, or when I stops changing. So when we print down here, that's when I is becoming 3. Yes?
Is there any way you can get the variable to just stay in the for loop and not be defined in the function?
Totally. And there's this thing in something called ES6, which is like a newer version of JavaScript. There's this declarer called let. So rather than do var I equals 0, you can say let I equals 0. And what that do is it confines any variable created only to the nearest block scope. Kind of like how continue only applies to the block scope, and now creates variables only in the block scope. We'll have a full lecture on let and const and other declares like in the last week of the bootcamp. So there is a way to do that. Up until like 2 years ago, there wasn't, and that was actually causing some headaches because people were like, I don't want to create these massive overarching variables every single time. You got to give me some other options here. So yeah. 3 questions. Anything else? Yes.
I'm just confused by the falsy truthy thing. Is that just fairly arbitrary?
Is that fairly arbitrary?
It's just some things are falsy and some things are truthy.
Yeah, so I think the best I can do is tell you what those falsy things are. I think a lot of it is open to interpretation, right? So something like an empty string. One language says it's falsy, another language says it's not. I honestly am not an arbiter on that to tell you why it is. I think sometimes it has to do with either how the people who make the language think that the user will want it to be, right? How they interpret it to be, right? So when you think about true, false in binary values, there's 0 or a 1, right? So there's, in that case, there's a precedence for 0 being true, being false, right? So there's some semantics for that. But in general, like, I don't know of any like consistent reason for why something is true and false. Right, no, there are like only a set number of falsy values. I think, yeah, I think I'm trying to say like I don't know why it's those 7 specifically. Yeah, Google JavaScript falsy. It will give you a very clear list of exactly what it is. But I don't know the reason why they picked those or why what JavaScript picked is different than what other languages pick. So sorry. My bad. Cool. Yeah. There is this thing called ECMA, which is E something 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 association. Basically, these are the people who decide what JavaScript is. And so they publish these standards called ECMA scripts, which tell you how JavaScript is supposed to be implemented, right? So the let thing I was talking about earlier, that happens in ES6, which is the 6th version of ECMAScript, which was released in 2015. Yeah.
But we're just focusing on 5 because mostly everything
Yep.
is used in 5.
Everything you see, it will run 5. 6, you'll see it runs, but not everywhere like consistently just yet. Although it will very soon because they also have ECMA 7 like in the pipeline or released at some point. I don't know. It's like it's a real thing. But all of that is to say that you might be wondering, well, why don't they change it to be more consistent in like a future version of JavaScript, right? To make it to kind of have a more kind of coherent thing. And the reason why they don't is because whenever you make any code changes, the biggest question that you always need to worry about is this backward compatible? Like tomorrow, if I say, great, 0 is now true, knock yourselves out, that's great. But for everyone who's running on legacy code that interprets 0 as false, they are totally screwed, right? And so this is one of those things where in every programming language, and Google some of these, right? They're like inconsistencies. Like there are things that are like conceptually inconsistent, we'll say, not wrong, inconsistent with every language. And the reason why they don't change them is because there have been people have been writing code based on that knowledge that inconsistency is a real thing, right? So that's why even when you see something in the language, it's like, oh, that's kind of weird. They really shouldn't do it like that. Every developer could agree with it. Like, yeah, I don't know why you do it. That's really weird. It should be this. But because it's been out in the wild and people have already written code on it, if they change it, they risk breaking everyone else's code who was built on that logic being wrong. So it's also something that just to be wary of is that like, hey, this language isn't perfect. There's a reason why they keep adding stuff to it. There's going to be little bugs and stuff. But a lot of cases, if it's fixable, they'll try to fix it. If it's not, then it's something you just kind of need to kind of grin and bear it, unfortunately.
So what was that video you said about the 13 different, the one you were talking about earlier?
The 13.
You're like, that cartoon or whatever.
Oh yeah, yeah. So that was actually more like everyone thinks they have like the newest and greatest way to do something.
Yeah,
and
so that kind of is example of what you're saying. So.
Yeah, kind of like that's just more like about like how like let's say linting, right? Like where we put semicolons, how we space, do we use tabs or spaces, which is a holy war fought in a lot of engineering teams, like things like that, right? Like everyone has like a way they want to do things, and so they always keep releasing newer versions. Like this is the latest and greatest. And actually, an ECMAScript is actually not that way because, like, ECMAScript kind of happens sequentially, which is good, right? Imagine if there's like an ECMAScript and then like an ECMA2 script and an ECMA3 script, all publishing standards at the same exact time. That's what happens in a lot of programming. So, like for example, this isn't the best example to be honest, but Python 2 and Python 3 are both out there. Python 3 came after Python 2. But Python 2 still gets updated and still released as a viable version of Python. So those two versions are running concurrently, right? And so that's like an example of like something where it's like the developer world actually hasn't reached consensus quite yet on like what the best next step is. ECMAScript, they actually do a pretty good job of having it released in sequence. It's like, okay, ECMA 6 is the next version of ECMA 5, and 7 is the next version of 6, and so forth. So in some ways, JavaScript has their act together a little bit better in some regards. But yeah, so there are going to be inconsistencies. If you Google them, you'll find enough threads, people complaining about them. It's definitely out there. Cool, that's 6 questions. Any others? All right, people just want to get started, don't they? Cool. All right, I will take a break. I will slack out pairs. Feel free to get started whenever you feel ready.